Project, heat transfer, questioning and predicting. What is Fourier's law? Fourier's law of thermal conduction states that the time rate of heat transfer through a material is proportional to the negative gradient in the temperature and to the area. This law has been applied throughout society, particularly in things like kettles, computers, stoves, and any other items that involve the transfer of heat. These products have benefited society by allowing us to sterilize water and remove the bacteria through boiling it. It allows us to communicate and research using computers, as it allows them to stay cool using the heat sink, and it also is beneficial as it allows us to cook food for flavor and sterilization. How can this be proved? To test or prove this theory, different types of materials could be sourced and then heat could be applied. The time it takes for the other side of the material to reach a certain temperature can then be recorded. Planning investigations. To investigate this question and attempt to investigate the nature of heat transfer, I gathered 4 different saucepans or pans of different shapes and sizes and applied heat to them on the stove. I recorded the initial temperature of the bottom of the pan in the middle and the initial temperature of the top of the pan at the back. I then applied maximum heat to the pan and measured how long it took for both the top and the bottom to each reach 65 degrees Celsius using an infrared thermometer. Processing data results. Here are the results of the experiment. It is evident that there is a correlation between the width of the pan and the time taken for the bottom to heat up. However, there is no clear correlation between the dimensions of the pan and the time taken for the top to heat up. Analyzing data. This data suggests that the wider the saucepan is, the longer it takes for the bottom to heat up. Potential reason for this could be due to the spread of heat application, since the heat from the fire of the stove has to heat up more surface area, as opposed to a larger volume, which would be the case with a thinner and much taller saucepan. Errors and uncertainties. Some uncertainties with this experiment include whether or not there is a correlation between the size of the saucepan and the time it takes to heat the top of the saucepan to 65 degrees, and is the reason there is no evident correlation due to an error in the experiment itself. Some potential errors with this experiment include the infrared thermometer itself getting hotter throughout the experiment due to it being close to the heat, and this can affect the temperature reading. The spot on the pan that the infrared thermometer is measuring could also move due to the use of a hand that cannot keep 100% steady for the entire time. This can also affect the temperature reading. Problem solving. Do my results correlate with the understanding of the topic? This topic and the law itself is quite hard to understand in its entirety, but based off some common sense, my results do partly correlate with my understanding. For example, it makes sense that the top of the pan takes longer to heat up than the bottom, and the wider the pan is, the longer it takes for the bottom to heat up. Personally, I am not sure if the overall time it took to heat the pans up to a certain temperature is correct, accurate, or close to what it should be. What could be improved? To improve this experiment in order to get results that cater more to Fourier's law, materials that are more solid could be used, and each side of the material could have its temperature measured as it gets hotter, as mentioned before. A wider range of materials could also have been used. Overall, this experiment measured heat transfer, but only of a more hollow material or object. A better planned experiment with better source materials would give results more suited to Fourier's law. Thanks for listening.